Hey guys, welcome to a new video. Today we will take a closer look at the new Nvidia GTX 1080 Ti. So this is the brand new card from Nvidia, and well, we cannot show performance numbers yet, but we can do an unboxing. And on my channel, of course, unboxing is not the typical unboxing. We will do an extended unboxing, which means obviously we will take the card completely apart, take a closer look at the components on the PCB itself, and we will also do a power mod. So yeah, stay tuned for that. First of all, yeah, let's take the card out of this box. And I have to say, I love the boxes from Nvidia. They really know how to do a proper packaging, I have to say that. Looks really, really good. So here we have the 1080 Ti. Looks really, really beautiful. And I have to admit that in the past I was not that much of a fan of the reference designs, but starting from GTX 1080, they did a very, very good job on the cooler design. I really like the look of this cooler. And one thing Nvidia improved on the 1080 Ti is the fact that they got rid of the DVI port finally, because in my opinion, nobody needs the DVI port nowadays. So obviously, I mean, if you're gaming in 4K, why would you need it? And so because they got rid of the DVI port here, there is much more room for the fan to blow out. So the exhaust is much better, means the fan can spin slower. The card will be much more quiet than the previous card. And yeah, that's a very good improvement. And what I also really like is the fact that if you want to equip the 1080 Ti with a water cooler, for example, you could get the EK water blocks cooler from the from the Titan X Pascal. The Titan X Pascal water cooler from EK also fits on this card because the PCB is nearly identical. And so if you want to get the card, you can already put that block on it. And if you put the EK block on it, you can actually turn this card into a single slot design. And that's something which is really, really cool. Because sometimes if you want to occupy all the PCI Express slots in your system, it could be that the slot here is blocking one of your expansion slots. So for example, if you would like to use another, I don't know, PCI Express SSD or sound card or whatever, it could be that this slot would block something, and if you turn it into a single slot design with the EK cooler, for example, that's really good. And that's why I really like that they got rid of the DVI port finally. So, well, let's take a look at some really nice shots of the card first. Alright, so let's take a closer look at the card itself, and first of all, let's compare it, the 1080 Ti with the Titan X. So here you can see the Titan X, and on the right side next to the inductors you can see some empty solder pads. And if you take a look at this picture, you can see all the parts which are now either removed or added. So on the left you can see the DVI port is gone, and you can see one of the memory chips is gone, and now on the right side you can see a lot of components which are added compared to the Titan X. So on the right side we have some tantalum caps which are added, and we have a lot of MOSFETs, actually 8 in total, which are added to the PCB. Now you can see on the right side you can the inductors which are marked with R22. Those are the inductors of the GPU VRM. And now you can see the yellow markings on the tantalum caps on the VRM of the GPU. Those are the MOSFETs, and on the top you can see 4 MOSFETs which belong to the memory voltage supply, and the bottom ones all belong to the GPU VRM. Now you can see the MOSFET drivers. Those are pretty much standard parts from Texas Instruments. There is not much special about that. So let's take a look on the back side of the card, and you can see the GPU voltage controller, which is sitting on the left. It's actually the same as on the Titan X before. and this one is controlling the GPU VRM, and the GPU VRM is switching at a switching frequency of 300 kilohertz, which is pretty much a standard switching frequency. Now let's talk a little bit more in detail how the VRM works on this card. So we have 3 power supplies to this card. We have the 6-pin, the 8-pin and the PCI Express slot. All of them deliver 12 volt, which essentially come from the PSU. Only for the PCI Express slot, obviously, the 12 volt go over the mainboard first. So now you can see 3 small resistors. They are marked blue, yellow and red, and those are the shunt resistors which are responsible for the power measurement. On the right side you can see the INA3221. This is the small IC which is actually measuring the power consumption over those 3 shunt resistors. And this small IC is also adding up the total power consumption from those 3 shunt resistors to the total power consumption of your card. Which means that if we mod those 3 shunt resistors, we can fool the power limit. So if you want to unlock the power limit on your GTX 1080 Ti, all you have to do is short those 3 shunt resistors with some liquid metal compound, and then you're good to go. So let's take a closer look quickly on the VRM area. I marked for you the GPU VRM area and also the memory VRM area on top. And I also marked them by color so you can see where the power actually comes from. So you can see 2 of the phases take their power from the PCI Express slot, 2 more phases from the 8-pin and 2 more phases from the 6-pin. So it's actually equally distributed, which is good. And the top part, the memory controller, 2 phases of the memory also take their power from the 8-pin PCI Express connector. Now what is really interesting is that in the middle there's actually a phase which I would call shared GPU phase, because this phase is taking the power from the 6-pin and the 8-pin connector. I'm not really sure if this phase takes the power from both at the same time, or if there is something which is power management related and then decides if it's either taking the power from the 6-pin or from the 8-pin. I'm not really sure. I didn't really see this before. One thing which is also different comparing Titan X and GTX 1080 Ti is the fact that the memory voltage controller can now select the voltage, well, it's a variable voltage. On the Titan X, for example, we had only 2 power states on the memory controller. So if you were sitting in 2D in Windows, it was a low voltage. And once you fired up your card and you went to 3D applications, you had the high 3D voltage. And now on the 1080 Ti, the memory controller can actually select a lot of different voltages from a VID table. And I think this is a lot better for power management, and should also allow the card to be much more efficient considering different power states. So that's it for this video. Obviously there will be other videos coming when we will do air and water overclocking, and of course also liquid nitrogen overclocking, and then we can finally also take a look at the performance itself. So I hope you liked this video. If you like it, thumbs up. I wish you a very nice evening. See you soon.